All right, so next problem, go ahead and go over is problem number 4. In this case, it says, write the expression in lowest terms. What is the domain of the expression? Now, I'm going to go ahead and go over this one, just because this one is going to work the same way once we convert the problem here. And you'll see how it goes. So in this case, let me actually write the expression on the bottom here. I have x plus 8 over x squared minus a 6x minus 7. And this is being divided by x squared plus a 16x plus 64 over x plus 1. Now, on this one here, guys, because we want to go ahead and simplify the expression, we are going to be factoring anything that is factorable. So, for example, if we take a look at the first one here, I really can't factor anything, so that stays the same. But this bottom one, I can factor. So I'm going to go ahead and actually factor that. So I want to go ahead and factor, in this case, the x squared minus a 6x minus 7. And if we factor that, in this case, that doing the diamond method, or if you guys do mental math in this case, that would be x minus a 7 and x plus a 1. Because in this case, we're looking for two numbers that multiply to the negative 7 at the same time add up to a negative 6. From there, this is actually also another one that can be factored. So we'll go ahead and actually factor that one as well. And we'll go ahead and do that in a different color. So factor x squared plus 16x plus 64. And that's going to be x plus 8 times x plus 8. Once again, two numbers that multiply to a 64 and at the same time add up to a 16. Now, one thing I want to go ahead and actually take a look at is because this here is division and we have basically a fraction divided by another fraction, we really can't do that. So this actually turns into a multiplication. The only way this could actually turn into multiplication is if we actually multiply by the reciprocal. So we have to do the reciprocal of this one here. So multiply by its reciprocal. Multiply by reciprocal. So in this case, that would become the x plus 8 over this in factored form would be x, once again, minus 7 and x plus 7 plus 1. That stays the same. Now we're going to go ahead and multiply. And the reciprocal in this case is actually just flipping this, right? Inverting it. So then I have the x plus 1 on top. And on the bottom, I have x plus 8 times x plus 8, right? And if you take a look at this here, it actually seems very similar to this one here. So how we work this one out, you'll actually be able to work that one out as well. So I'll just go ahead and show one. So from here, because it's multiplication, we could actually do some cross canceling. If you see things in this case repeating on top and bottom of separate fractions, you could cancel them out. So for example, x plus 8 and x plus 8 is repeating at least once on top and on the bottom. We also have the x plus 1 and x plus 1 being repeated there. So in this case, what we're left with is actually going to be 1 over x minus 7 and x plus 8, right? So that would actually be the simplified form. That would be the simplified form. From there, we still have to state the domain. And the domain in this case, guys, we're actually going to go ahead and focus it from what we have in the denominator. We could have actually also started the domain from here, but since we ended up doing the flip, I'll just go ahead and focus on this one here. So the domain for this one is, once again, is x is all real numbers where x cannot be certain numbers. Once again, the values of x that we're restricting are the ones that are going to make the denominator equal to 0. So if I were to solve for x on this one, x would actually be a positive 7. So it can't be a positive 7. It can't be positive 7. It can't also be, in this case, the one we excluded, which if we solve for x there is going to be a negative 1. And these are actually the same, x plus 8, x plus 8. So if we solve for x there, it can't be a negative 8 either. So that would actually be the domain. All right, so this is actually our final answer. All of this here. All of that there.